So I've got about 85 slides to go through. In the next couple minutes. No, this is the one and only slide for me. I'm not a big slideware guy. I'm more of a talk guy. Let's interact a little bit. Want to talk about a little bit about the way that PG&E is approaching this, and kind of building on that statement that Dave said earlier about one size doesn't fit all. The story of PG&E and private LTE really started about 5-6 years ago. Me and my boss were out there looking at different LTE technologies and trying to figure out how, in the age of everybody at PG&E being only concerned about wildfire, we actually got them to think a little bit about private LTE. And what sorts of wireless solutions we were going to implement to control our grid. And at that time, if you didn't walk in and the first words out of your mouth weren't, this is how we're going to reduce wildfire risk, you pretty much summarily got dismissed from the room. So for the first 3 years, every time we'd walk in and say, hey, this wireless solution might be able to help us, we'd go, yeah, but it doesn't stop a wildfire right now. It doesn't stop sparks from falling on the ground. Go away. We're spending all of our money on that. The funny bit was a couple years later when Southern Cal Gas, or Sempra Energy, bought some spectrum in the CBRS auctions and did a deal with Anterix and bought the spectrum with Anterix. And then our other neighbor to the south, Southern Cal Edison, they spent a bunch of money at the CBRS auction. A few of our executives went, hey, they're doing a private LTE thing. Have you guys ever heard of that? And we said, funny, we've been trying to talk to you about that for about 3 years now. So we went through, and there were a couple of things leading into, your political environment and what suits your company at the time that you're at that I want to kind of talk to on this slide. So there's a couple things. One was what Dave alluded to, the price of the spectrum. That's the tip of the iceberg when you get into private LTE. The numbers that he's talking about, depending upon the band, we heard about this a little while ago, right? If you make a decision to get 600 or 800 or 900 or 1.6 or 3.65, every one of those decisions leads into a number of sites and range and capacity that you need to start thinking about in terms of what your solution is going to look like. So as you hit those spectrum pieces, you're going to get like you said, a megahertz pop price. Well, in PG&E's territory, let's just boil it down to some raw numbers. We have 17 million pop. If we're multiplying that by the size of spectrum that we're talking about for CBRS, maybe it's a 5 by 5. Simple math, 10 megahertz, 17 million, 170 million. Now I get to take in that number that's the price per. So my base at $1 is 170 million entry. And going to PG&E executives and saying, okay, well, if I'm looking at a spectrum that's going to cost me $2 per megahertz pop, minimum, median of the range, $340 million. Cut me a check for that. I'll get some spectrum. I'll go try to put my first device on the network at $340 million for one device. Pretty expensive when you compare, well, I can get a SCADA device on another, traditional spectrum at about $10,000 for my device. The good news is it comes down rapidly. The second device is only 170 million per device. The third device is only 110. So, you get that down ramp, real quick as you start adding devices. But it's still a pretty big number, right? And like I said, depending upon your spectrum selection, the number of sites you have to build to get your coverage can be a big number. When we were looking at different spectrum selections, we were looking at anywhere from 500 to 1,500 sites to actually cover our service territory. And when you start talking about $500,000 a site, $1 million a site, makes that initial $340 million number look pretty small. So that's what's kind of the economics behind PG&E and going to the decision, right? Is at the time that we're going to our Public Utilities Commission and looking for this money to say, hey, we're going to go invest in this, is this even the right thing to do? And with the numbers we're talking about, we're going to Patty Poppy, our CEO, we're going to the chairman of the board, Bill Smith, who also has a political contribution to this, used to be a vice president of engineering at a little company called AT&T, who, when we got into a room with him and said, hey, what do you think about us building this PLTE thing? He said, there's no way in heck, he did say heck, that you are ready to build a private LTE system. You don't have the personnel for it. You don't have the training for it. You don't have the way to build these sites. You don't have the people who know how to acquire facilities. You don't have the people who know how to go to municipalities and get towers permitted. You don't even know the tip of the iceberg that you're dealing with. And we said, yep, you're right. So these are all things that, between the political and the economic conditions, let us say, well, we still do have a need for private LTE because there's a whole bunch of California that those carriers don't cover. We've got hydro sites that are in the middle of canyons in the middle of nowhere. We need to have the ability, especially for what was talked about earlier, for people to have a device that can roam and say, get on our network when you're down at the hydro plant in the bottom of the canyon where AT&T and Verizon and T-Mobile are never going to cover because there's no population for them down there to ever build coverage to get to. And then when they get back out into civilization, they can roam back onto Verizon or AT&T or T-Mobile. So that's kind of the thing that's, I'm a bit envious, right, of the folks like Evergy and that have been able to build a private LTE network. I'm in the business of building stuff, so I would love to just go, hey man, I got $2 billion. Let's go build some LTE, baby. Let's roll. But where PG&E's at, where we're at in this time, it's probably not the right thing to go ask our ratepayers to pay for. It's not the right thing to go ask our management to fund. The problem is we still have a need. We have growing SCADA needs. We have people that want to do more with a wireless network than the traditional pull and response SCADA. They want to be able to control devices. They want to be able to configure devices, download oscillography reports, all this other fun stuff that we can't do over traditional 12.5 kilohertz SCADA channels. So then, maybe the LTE, global coverage thing that other folks are doing, maybe that's not the right thing for us right now. But what do we do? So when we started doing the what do we do, there was a guy named Bob Finch here who had some spectrum. Previously we bought some spectrum from Mr. Wiesenberg in the back from Space Data. So there's spots where you can buy spectrum at a much lower rate, right? The general inputs on the spectrum costs is the wider the spectrum, the more it's going to cost, right? The lower the spectrum for propagation, the more it's going to cost. If it's nicely paired, like Dave was alluding to, the more it's going to cost. If you start violating and taking away a few of those things, you can bring that per pop price down quite a bit. So what we ended up doing is aside from the 900 spectrum we bought previously, we bought some 220 spectrum. It was available at a much lower price. From a propagation standpoint, we can overlay that with our 900 meg. It's going to, because it's lower frequency, it's going to go further. It's going to penetrate better. It's going to really augment our 900 system. And it's going to give us, if anybody was in this room earlier, the dual band sort of coverage where we have, a 900 spectrum we can use when it's available in a service territory and have a certain amount of bandwidth available on it, and a 220 that overlays with it, and have additional capacity to get our total bandwidth, at a given site up a bit. We already talked about the targeted PLTE coverage to enhance. Because we're going to have a lot less sites to build, it's just going to be a much more rapid adoption for us. We can go to our existing sites. We can deploy the existing antennas that we all know how to work with, and get a better coverage footprint at 220 than we traditionally have at 900. So we've got our maps that show us, okay, here's the 900 system and here's what it'll cover and here's how much stuff you can do with it. You overlay 220 on top of that. One of the things that we haven't talked about yet was one of the things that we're doing with the 220 is we're sectorizing it. So the spectrum we got was a total of 975 kilohertz, 950 kilohertz, depending upon exactly what county you're in, but just short of a megahertz. Sectorizing that, doing 50, the biggest channel we can put together in that band is 50 kilohertz. So we can sectorize 50 kilohertz, use 150 on a site, overlap the frequencies, get some pretty good coverage maps. We're in the middle of doing that, so I can't reveal any results yet. But there are other folks that we've seen in the industry that have taken a similar approach and gotten some really impressive throughputs. Not cellular impressive, not, I'm going to watch YouTube videos impressive, but the ability to do the things you need to do with a SCADA network to control devices, download devices, reconfigure devices, that sort of thing. So that's where we're at, is the right solution for PG&E right now. Like I said, I'm still a builder. I would love to get to $2 billion. I would love to go build this stuff, have massive amounts of spectrum to go play with, but that's not the things in the cards for us right now. So as you guys think about your options and what you're looking forward to, love the LTE play, love the huge bandwidth, but analyze where you're at in your company, your situation, see what's the right fit for you. That's my spiel, and now we're off to Bob.